Hey, how's it going, PreCalc class? Hopefully everyone is doing just fine, and hopefully you've taken a second to look at some of the work I gave you. If not, I'm going to be posting videos. I decided Monday, Wednesday, Friday to go through kind of what we would have been doing in class. So I'll post here today on Monday, give you a couple days to have any questions or concerns on that. You can shoot me either an email or note it below in the comments of what questions you'd like to look at for homework. And we'll talk about those on Wednesday and just kind of continue that pattern from there on out. With that, let's look at section 7.1, which is all about solving systems of equations. So if we had this equation here, x plus y equals 4 and x minus y equals 2, there's a couple different ways we could go through solving this. The way we're going to be talking about today, that hopefully you've seen before, but if not, it's a good refresher, I guess, is some substitution. So really what's going on in substitution is you're going to solve for one variable and then use this in the other equation. So given our two different equations that we have here, let's pick one of them and solve for one variable. It really doesn't matter if we're solving for x or for y, or if you're picking the first or second equation. It's completely up to you. Let's, for the sake of argument, just pick this first equation and let's solve for y. Great, so from that first equation, we have that y equals 4 minus x. From the second equation, we had this. So we want to take this 4 minus x and we want to put that in for the y term here. So what we're going to do here is we get x minus, keep in mind it's this whole term that we're going to be using, the 4 minus x, and that equals 2. Now we just go through, solve a little bit of algebra. From here we're getting what? 2x minus 4 equals 2. And then we're going to add the 4, divide by 2, and we're left with x equals 3, should be what we're getting here. But we haven't solved for the whole thing. That's just the x term that equals 3. From this point, we're also going to have to solve for y. So now, solve for the other variable. So I recommend taking this term here and putting it into the equation we had before. So since we're told here y equals 4 minus, instead of x, we're putting our 3. Some big brain math here is going to bring us all the way to, hold on, let me count, 1, yeah. So we should have a final solution here of 3, 1 that we're looking for. Now, in case you're uncertain or double guessing yourself as, is this right, is this not? What's great about all of these systems is that you can always check them. So the nice easy check to perform is take the original equation and plug in the answers you have. So here we had 3 and 1. Does that equal 4? Yeah, pretty sure it does. And it's good to always check it in both of them. So our other equation, okay, some more advanced math here. Does that equal 2? Yeah, still feeling pretty good about that. Okay, hopefully this is something, like I said, that you've seen before last year in Algebra 2. If not, we're going to be working on it throughout this whole section. Let's take a look at another problem here. Getting into word problems. So here we're told that a total of $12,000 is invested into two funds which pay at 9% and 11% simple interest. So the yearly interest that they're going to make is $1,180. How much is invested in at each rate? Okay. So a whole lot going on here, but the goal is hopefully here to be able to set up two different equations, systems of equations here. So a total of $12,000 is invested into two funds. So how we can kind of denote this first bit is that we could say x plus y is going to equal 12,000. Now the next is that they pay at 9% and 11% simple interest. And that these are going to give us an interest of 1,180. So I think the best way to denote this is, let's say the first one pays off at 9%, the other one pays off at 11%, and we should be getting $1,180 off of this. Notice since they're in percentages, we need to have them as decimals. So 0.09, 0.11. Okay, hopefully everyone's good from here. At this point, let's see if we can try to solve this system of equations. So we want to solve for one of the variables, whether it be x or y, and then kind of reinsert that into the other equation. Not really looking forward to dividing by either 0.09 or 0.11. So how about we stick with this first one here? And let's just solve for x here. Okay, since we have x equals 12,000 minus y, we can reinsert this or substitute it back into that other equation that we had here. Okay, unfortunately what we will have to do is multiply 9 by 12,000. So this one is going to come out to, once you go through and do that math. However, I think I did this just multiplying it by 9, so I do have to remember to move my decimal points 2 more. So it's actually coming to here. Let's get rid of that. So really that's 1,080 minus 0.09y plus 0.11y. Okay, let's combine some terms here. We can subtract that final term over, which is going to leave us with what? 100. And if we're dividing by 0.02, same thing really as multiplying by 50. So 5,000 should be the amount that y is. Now we want to solve for what our x value is. Since we already have an equation for x equals up here, we can take this and reinsert it up here. $12,000 minus 5,000, left with a $7,000 investment here. So 7,000 there, 5,000 here, and at this point I would usually check my math as well. 5,000 plus 7,000 does equal 12,000. If we're solving for this other one, this becomes a little bit more complicated, but let's do it quickly. A nice little check here. So we said the x was a 7,000. Ooh, running out of room. Okay, 0.09 times 7. 7 times 9, that's going to be probably 63 here, with 2 decimal points moving over, so 630. 11 times 5 with 2 decimal points gone. And that does, in fact, check out for us. So not that bad. Okay, most of the way through this section already, since hopefully this is just a repeat of things you've seen before. Let's look at another system of equation, but this one's slightly different compared to the ones we've just been looking at. Hopefully everyone can identify that the big difference here is going to be that x squared term up top. Everything else we've been doing had been purely linear. At this point, we have a quadratic kind of introduced into our system of equations. Still, the best philosophy here, I think, is to solve for one variable, insert it into the other, and go from there. It's not necessarily as easy to solve for x due to this x squared being there, so I think it might be a better idea to maybe solve for y and put that into the quadratic equation. So let's take this second equation and solve for y. So y is going to equal here 2x plus 1. Once we have that 2x plus 1, we can go back to the first equation and put that in for our y term. Right, that's coming from the equation up above. Let's combine like terms, get everything to one side, and see if we can get anything going here. X squared, 4x minus 2x, leaves us with plus 2. We have minus 1 equals 7. Let's bring that 7 over to the left side as well. Okay, so we should be down to x squared plus 2x minus 8 equals 0. Since we're in a nice quadratic form, let's try to factor. So we're looking for two terms that are going to multiply to 8 and then add to 2. So we're thinking positive 4, negative 2, which means the actual solutions here, x equals negative 4 and x equals 2. So it looks like we have two different solutions here, which is also slightly different from what we just had. Well, let's find out what their corresponding y's would be. So for the negative 4, the equation